So let's think about where we are in this section. We have been factoring, so we're writing things as a product. So the first thing we learned was to factor by GCF. Then we learned to factor by grouping, which was a special kind with 4 terms. Then we started into a big family, trinomials, and we did the nice ones with they call it a monic trinomial. It means it has a leading coefficient of 1. So they turn out nice. And then last time we did the harder ones, where we had another number there, and we looked at 2 different techniques we could use. We could use trial and error, or we could change the problem and do it by grouping. All right, so that's kind of where we are. This section has 3 different kinds of problems in it. It has some problems that are 2 terms, and we have 2 types that are 2 terms. We have difference of squares. They have to be 2 terms, they have to be minus, and they have to be perfect squares. We have cubes, and cubes can be plus or minus, and they have to be perfect cubes. And then we have one more group of trinomials, and these trinomials are what we call perfect square trinomials, and they will have a square at the front and a square at the end. And I'll talk more about it when we get there, but 3 different kinds of questions in this section. And you may have to do GCF on some of them. You can always try GCF. All right, so we'll just get started. So problem number 1. I forgot to do my calculator. Give me 1 second. Sorry, guys. Let me pull it up. I thought I had everything ready. And I don't need it right now, but though it's here. Okay, so problem 1, and all of these say factor. So I'm not going to write factor every time, but that's what we're doing. This one you could do squares, but that's not the best way to go. The best way is always to try a GCF first, right? There is a 4 that's in there. So if we take a 4 out, that leaves us a w squared minus 9. So GCF, and you can kind of check it back. Now, this problem is 2 terms, it's minus, and it has perfect squares. That's going to be a difference of squares. Your 4 is just coming down. This is the nicest kind of problem that you can get for factoring. It will use your square roots with a plus and a minus. So WW and square root of 9 is 3, and you're done. You don't have to check these because they're such a set pattern. If you do check it, when you do outside and inside, they're going to cancel. You will get minus 3z, 3w, and plus 3w, and they would wipe out. You don't have a middle. That's why you cannot do the plus ones here, because the plus gives you like signs, and you wouldn't cancel. So you'd have an extra term. All right, and hopefully you did listen to the other notes that have more. If you started this problem, let me just sidetrack a second. If you started this problem and you looked at it and you said, oh, that's squares, you would be right. So this is not the best way. I showed you the best way first. All right, if you looked at it and you said, oh, that's squares. Let's do a 2w plus 6 and a 2w minus 6. Right? If you check it, it's going to work. The problem is it's not factored completely. It leaves a common factor in the parentheses. So now you would have to take out a GCF, which is a 2, and that leaves w plus 3. Oh, and this one also has a 2, and that leaves w minus 3. Now this is not a grouping. It kind of looks like that. It's just all multiplication. So put your 2 2's together, and you get to the same final answer. You can just get a little tangled up this way if you miss it at the beginning. So it's always better, look and see if you can find a GCF. That'll make it a little bit easier. All right, I am going to skip down and pick number 5 because I like it better to show you perfect square trinomials than the way they have started out. So we see this problem and we would look to see, okay, is there a GCF? There's not. Now, if we only knew those methods from last time, we would have to go the trial and error or the grouping. And 25 and 64, well, those are kind of big to do that, Mrs. H. So what we have one kind. If it has a square at the front and a square at the end, which this one does, so you can get a square root, it is probably a perfect square trinomial. So we're going to make that guess. You do regular sign rules. This says like signs both plus. And use your square roots. So 5x for 64 square root would be 8. Now you have to do one check. You have to check this middle. About 95% of the time this will work if you have that other setup. So this will be 40x on the outside plus 40x on the inside gives me 80x, and I'm good. So it is a perfect square trinomial. Sometimes you will see this one written a different way because the parentheses are just alike. You might see it written like this. I would never bother to write it that way just because you can't check from that form. I would just write it this way. But if you see it that way, it is correct. It's for a perfect square trinomial. And that is how they have it in the key. Okay, but they would accept the other one. All right, now we'll back up and get those others in between. So if we go back to problem 2. So here is another trinomial. And you want to always check for GCF. This one does have a GCF. You know at least it has a 2, and I am hoping it has a 4. So I'm going to pull this calculator. 4 does go into 64. Let's just check 256. 256 divided by 4. So, yes, it goes into 256 evenly. So, excuse me. So we're going to do a GCF first of 4. Remember, GCF is one set of parentheses. So we have r squared plus 4 goes into 64 16 times. And this one we said is 64. All right, and now, it doesn't want to move. Okay. Now, this piece is a perfect square trinomial, but it is actually the nice kind of trinomial from before. So whether you even think of it as a perfect square trinomial doesn't matter. It does have a square here and a square here, so guess the square roots, like signs both plus, and this we would try an 8. You still check the middle. So 8r plus 8r gives 16r, so we're good. But if that's all you saw, I don't know that I would even think perfect square trinomial. But it is, so we're good. All right, so that's the same. All right, let's see. What about this problem? This one has something to the 3rd power. So that is a clue right off that we need a GCF. And these numbers are ridiculous. So another clue that we should try GCF. So we will definitely take a y. And 5 goes into all of these because they end in 0 or 5. So we are going to do GCF of 5y. Remember, one big set of parentheses. All right, to get back there, we are missing a y squared. And 5 into 12 would go 1. So 14. Use your calculator, Mrs. H. I better check that. 120 divided by 5. Good thing I did. Would you guys have told me? All right, and then 720. $144. All right. The 5y will come down. This is going to be a perfect square trinomial, but you can try it that way, or you can just do your parentheses and see what happens. But because this first is squared, you can use the square root, and this last is squared. Both have to be squared. It is, and like signs both plus, just check and make sure that your middle works out. So outside we have 12y, inside 12y, and that gives, I messed up here. This is a y, because we took that y out, one of those y's outside, right? That gives you 24y, not 24y squared. All right, sorry about that. So fix it if you were copying. All right, and then they're switching us back, and this one can fit on the same page. This one is the easy one. You're going to realize that these squares are the nicest of all the problems that we have. All right, so this one has switched from 3 terms back to 2 terms. 2 terms, your choice is squares or cubes. Your exponent determines that. So an exponent of 2, you have to try squares. This is a perfect square. It ends in a perfect square. And these have a set pattern. You do get the 2 parentheses like FOIL, always different signs. And it's going to be your square roots. 5x, 5x, and 3 and 3. And it's good. Make sure you have different signs. Let's see, about 6. All right, this is also a problem with 2 terms. So, and right now it's not perfect squares. It does have a GCF. So it has a 3. We'll take it out. To get back there, when you're missing x squared minus 4, and oh good, there is a perfect square. Difference of squares. Whoops. Keep your 3. This will give you x plus 2, x minus 2, and you will get that fast with that kind. You should never miss that kind. Right, 7, it's 2 terms. Exponent of 2, our candidate is also squares. And so we'll see 2 sets of, and I don't have a GCF. I should think that first. Different signs, so 6x and 5 and 5. So it works. We're happy. It's good. And it doesn't matter about your order of those. 8, this one you could do in your head so fast. It's going to be r plus 7, r minus 7. It would be that fast. We'll even fit it right on here. You should never miss one of these. Okay. All right. Let's see what else we have. So, 9. A little bit bigger numbers. But think of your problem as a whole. There is no GCF. It is 2 terms. Exponent of 2, that's your thought process. And so you're going to go to squares. Is it a difference of squares? You just have to check 121, and it is a perfect square. Your square root is 11, but you would check on your calculator if in doubt. So square root, so for this calculator, it's second and square root, 121, close, enter, and it's 11. So it's going to work. And 25, I think you would know, 5 and 5. So do your parentheses, different signs, so 11y and 5 and 5. Ten just has a different order. I would leave it in that order. You don't want to mess up the signs. And I didn't copyright. It's 49. I would leave it backwards. Okay, it's one I would not change. And it is squares. So for 49, square root is 7. It would go at the front because it is at the front. Plus and minus, and your W's. I would leave it just like that. All right, then they're throwing us back to a trinomial. And this is one that, even if it wasn't a perfect square, you could do it very easily. It does have a square at the front and a square at the end. So it's going to be perfect squares. To guess, right? Like signs both plus. So split your x's and 5. And you could have gone the other route with you multiply to get 25, add to get 10. Right? And it would have still been 5 and 5. If you're thinking perfect square trinomials, check. Outside and inside, 5x plus 5x needs to give you 10x. And it does, so it's good. It is a perfect square trinomial. Let's see, 12. This is a better candidate for a perfect square trinomial. I don't even think of it with those. But this one, because this would be harder with our other methods, it kind of stands out as a nice perfect square trinomial. And there is no GCF. If there was GCF, we'd do that first. But hopefully what you would notice is this is a perfect square. Square root is 4x. 81 is a perfect square. The square root is 9. So this is a good candidate. We'll have to check for the middle, but it is a good candidate for a perfect square trinomial. That is so much easier than going to trial and error or our other method. So, and this one, your rules are regular sign rules. It ends in plus, so they'll be alike. They'll be whatever this one is. All right. And our check, remember, outside and inside. So 36x plus 36x gives us 72x. And we're good. So it did work. It is a perfect square trinomial. All right, I'm just going to skip 13. And I'm going to skip 14 because it's actually, the only thing different on it is it has minus instead of plus, right? So it would just have minus in here. Otherwise, it would be the same. So I'm going to skip those two. All right, this is a nice question because it lets you compare some things that look very similar. So our first one is 12y plus 75. All right, your only possibility here is GCF. And the reason is because the exponent. The exponent on this one is 1. It is not 2 or 3. So GCF is our only choice. There is a GCF in this problem. It is a 3. It might not be something you think of because they're not both even, but there is a 3 that would work. And so you'll take it out. Remember, one set of parentheses. That gives 4y plus and 3 into 75 goes 25, right? And that's all you can do to it. It's not squares, it's not a 2 here, and it's not minus, so you can't do difference of squares. So that's all you can do. So that is the first one on there. So all we could do is GCF, but it factored. Right, the next one, all right, we can do GCF here. Now this one is a 2. So a little different than that one, but we can still do GCF. This will give us a 4y squared plus 25, right? You have to be careful here. You cannot do squares on this one. It looks like a square here, it looks like a square here, but it is plus. Different than squares has to be minus. So this is as far as you can go on this one. Right, and the third one there, 12y squared minus 75. Do your GCF. So we take the 3. This one leaves us 4y squared minus 25. And this one is giving us squares. It will do more, right? Because we have a minus. So your 3 will come down. And this will give our squares. So 2y plus and minus 5 and 5. So you have to watch for those. To do difference of squares, it has to be minus. And I didn't see a problem in your section like this, but if you end up with one that looks like squares, but it's plus, and nothing else, like if this piece right here was all I had, 4y squared plus 25, it didn't have any GCF or anything else, this would be prime because it's not minus and there's no GCF, so there's nothing you could do. All right, so that was just a for instance. All right, so number 16. Ooh, they're taking a jump with those exponents. So we have to see what happens. Definitely try GCF here. We don't have a method for that high, but we do have a GCF. And I think only the variable, whoops. We can't even do a variable, because it's x squared and y to the 4th. So let Mrs. H rethink this. I looked at it wrong earlier. So we're going to have to play with this one. All right, we could not do a GCF. Is there something squared? We do have squares here, and we have minus. Is there something squared that gives us x to the 6th? All right, so if we did, so we're playing. If we have x cubed and we square it, all right, and that would mean times itself. So if we have x cubed times x cubed, that would give us x to the 6th. So this is the square root, or here they would multiply. So x cubed is going to be the square root. We can find the square root. All right, so our square root is 3x cubed. Right? This one, our square root will be 8, and for y to the 4th will be a y squared. So we actually could get the square roots. Now I'm going to erase this piece where I was just checking. Should have put it over here. I'll move it so that if somebody looks at the notes, they can kind of see what we did. So, and we had to try something different because it's not a normal problem. Okay, This one is not a normal problem. These are too high. And we could not do GCF. But otherwise it did look like squares, being minus, and the 9 and the 64 were squares. So we tried to see, could we find a square root of x to the 6? Right? And if it something, we made a guess, what would go times itself? Right? And x cubed does. So that works. And then for y to the 4th, that one even is a little easier, y squared. So your answer would be these pieces with a plus and with a minus. Right, and we will look at this to see. All right, good. So we were okay there. That one was kind of out of left field. All right. So let's look at 17. 17 is 3 terms again. And there is no GCF. We do have a square at the front and a square at the end. So perfect square trinomial is our candidate. Regular parentheses, regular sign rules. So this is do like signs, both plus. Right, and for 9 we can do 3W. For 25 we'll do a 5. And you still have to check. So outside and inside. 15W plus 15W. That does equal 30W. So we're good. It is a perfect square trinomial. All right, now we're moving up to our other kind of problem that we have in this section. We haven't done any of these yet in this section. These are the cubes, and they are going to be 2-term problems. And the way you tell them apart from the squares is the exponent. Right. With cubes, they can be plus or minus. Squares could only be minus. And you have to be able to get a cube root. So you're going to have to test these each time. If so, then it'll be a set pattern. W cubed is W. 64, your cube root is a 4. Let's remember how to do that on the calculator. So for a cube root, I don't have a cube root button on here. So I have to do a 3, second, and the any root, which is right here. Right, so the 3 is really going into the x. And then put the 64 in. So my cube root is 4. I could get the cube root. If you can get the cube roots, it's going to factor. And this has a set pattern. Maybe I'll put it below instead of out here just to make it have more room. Right. It will do one binomial with these roots with the sign of the problem. And then your second piece is a trinomial. This is the only kind we get like this. And for your signs in here, the first sign will be the opposite of this, and the last one is always plus. So this will be the opposite. This one is always the sign of the problem, and these are your roots in the first one. Last one is always plus. Last thought of the day should always be positive. Maybe that'll help you remember. All right, now these other 3 pieces are going to come from multiplying all the combinations of your roots. So you're going to do first root times itself. So first times first goes in the first spot. All right, this was W times W. Then you're going to do the first root times the second one. W times 4 is 4W. And so we did that one times itself. And so now we'll do the last one times itself. 4 times 4 is 16. So first times first here. First times second goes here. And second times second goes at the end. This trinomial will not factor more when it comes out of a cube. So you're able to stop there without trying. It looks like it would factor more. I mean, it looks like a nice trinomial, but it doesn't work. So, very set pattern with your cubes. Right, we'll try one that is minus. So we have r cubed minus 27. All right, it's two terms. What you want to see next is this 3. That tells you try cubes. All right, so if we can get cube roots, it'll work. Well, this will be r. Cube root of 27 is 3. If in doubt, check it. It's going to work because we could get the cube roots. So, one parenthesis with these pieces, sign of the problem. Second set is a trinomial. For your signs in here, the first one is always the opposite, and this causes canceling. You're multiplying 6 things here, you're going to get back 2. All right, you need some canceling. So this is an opposite sign. And last one is always plus. Right, now to pick up these 3 pieces, you want all the combinations of multiplying these roots together. So first times first, r times r is r squared. Right. First times second, I'm going to write below what I did. Right. First times second, so I did r times 3 is 3r. And then I'm going to do second times second. 3 times 3 is 9. And you're good. You don't have to do anything else with it. It is done. All right. For 20. You might think GCF on this one because it has extra number, but it's actually not a GCF. All right, so it is 2 terms. Your choice is squares or cubes. The 3 tells you to try cubes. So you just have a number and a variable that you need to get cube roots on. 8 is a perfect cube. It is a 2. So here you're going to have a 2r. 125. The cube root is 5, and you can test it on your calculator if in doubt. It's going to work. If you can get those cube roots on this setup, it's going to work. All right, these pieces with the sign of the problem. So 2r minus 5. Second set is a trinomial. For your signs, the first sign in here will be the opposite. Last sign is always plus. Right, now you want all the combinations of multiplying your roots. So you're going to do first root times itself. So 2r times 2r gives you 4r squared. Right, you're going to do first root times the second. So 2r times 5 is 10r. Then you're going to do the last one times itself. 5 times 5 is 25, and you're good. Nothing else you can do there. This looks like a perfect square trinomial, but it's not. It wouldn't work if we tried it. All right. And I don't know if I even looked at the answer there to check the answer. All right, I'm going to skip 21 for a minute, do 22, and I'll go back to it. It's tricky. I made a note of that on my list. So we'll do 21 and then go back. This one, you have a to the 4th, so kind of a weird exponent. So you look a little closer, and this one has a GCF. It just has an a in it, GCF. And then that leaves us 27a cubed plus 64. Now, this a will be with your final answer. This is a sum of cubes. All right, so you can take your cube roots here and go. So we're going to do that. We just have to remember at the end we need this a. So I'm going to bring it down and kind of get it out of the way. So we get the cube roots. For 27, cube root is 3. For a cubed, it's a. For 64, the cube root is 4. Right? And it's going to work. So you're going to do a parentheses with these pieces with that sign. So 3a plus 4, a big trinomial. And your signs. Opposite sign first. Last one is always plus. Now you're going to get all the combinations of these roots. So first root times itself. 3a times 3a is 9a squared. First root times the second one, 3a times 4 is 12a. And last one times itself, 4 times 4 is 16. And you're good, and I had already brought the a down. So we'll just check that. So we're good there. All right, now we'll backtrack to that one that I said is tricky. 21. All right, so we have two terms. We have no GCF. We are looking at sixes here. So we want to see, I think this one will be cubes instead of squares because of the 125. All right, so I'm going to see if I can do something and then cube it to get 6. All right, so I'm trying to find a cube root, guessing here. For 125, it's easy. It's a 5. And for 64, it's easy. So variables we have to work on. So we just kind of guess on the side. If we try x squared and cube, that gives us x to the 6th. So that is something squared. So the x squared would be the cube root. If we did x squared times x squared times x squared, 3 copies, yes. So x squared is the cube root. Right? And so for this one, it'll be similar. So it will be y squared will be the cube root. So we did get cube roots here. So first set of parentheses, we'll use these pieces with the sign of the problem. Second set is a trinomial. For your signs, the first sign is the opposite, so that's minus, this will be plus. Last one's always plus. Now, we're going to do first root times itself, so 5x squared times 5x squared will be 25x to the 4th. Okay. Then we're going to do first root times the second one. So the 5 times 4 is 20, and you're going to have x squared y squared. Right? And then the last one will be 4y squared times 4y squared will be 16y to the 4th. This won't do more. This I was a little worried if it would do more, but the 5 makes it not do more because it could go to squares there if that was a different number. So let's look and check this one. So 5x squared minus 4y squared, and we're good there. All right, so we finished this whole section. And that's all I had for you guys today. We don't have a section that really tests pulling everything together. I did have a video on it in the other part in your shell. But let's just go over it a little bit. All right. So if something just says factor completely. So this is your strategy. And there's a nice little diagram you can print out from in there, right? Step 1 is take out a GCF, right? After that, you're going to put the problems in categories. Step 2 is look at how many terms are there. So we have problems with 2 terms, problems with 3 terms, and problems with 4 terms. All right, now we've already done GCF at this point when you're at level 2. All right, 2 terms, these are the 2 of the new kinds we learned today. So you have difference of squares, which is something squared I'll take that parentheses off. And it always gives you a plus and a minus. Right? And then we had cubes. And cubes, we did it with the pattern. You can memorize the formula. It can be plus or minus, and I'm just going to make a note. We did it by the pattern. All right. Let's leave 3 terms a minute. Let's go to 4 terms. 4 terms was grouping. It's kind of a special method. 4 terms is your clue for that. All right, 3 terms. First, we had the nice ones that were something like this. All right, and you make your 2 sets of parentheses like a backwards FOIL. You multiply to get the last one and add or subtract depending on your signs to get the middle. That one was pretty easy. Then we went to the ones that are harder. So if we've already done GCF and we're here, the next kind I would think about would be the kind we looked at today. So if you have a number in the front, is it a perfect square trinomial? Because that has a nice pattern. It has to have a square at the front and a square at the end. And if so, you guess those and then check. Guess the square roots and then check. All right. If it doesn't have that, and that's obvious when you look at it, whether it has it or not, or at least a candidate. After that, then you go to trial and error or grouping because you have the trinomial that is not so nice, like we did last time. All right, so you've done all these kinds of factoring, and your next question that people often ask is, how do I know when I'm finished? And the clue is the exponent. If the exponent is 1, the only kind of factoring you can do is GCF, or if it's 4 terms grouping. But we've already gone through that cycle if we're at this level. All right, so if the exponent's 1, you can try GCF. If the exponent is something else, like a 2, 3, or 4, you would have to go back through and see, is it one of these? Normally it would be like a 2 that's left, or a 3. And then you would go back into your categories and see if it fits somewhere, right? I don't have room to write all that. But so you would just start the cycle over. It just kind of helps, I think, to put these in categories when they're, because next we'll start solving equations with these, and they're all going to be mixed. And you'll have to factor it to solve, but you don't have any idea which kind of factoring it is, right? They're not all from one section. So to me, that's the hardest part. And I do hope you'll go back and go through that video about the factoring strategy. It will be in your module folders on the left toolbar, and probably the study tools. Let's see. I have time. We can just pull it down here. I just want to show you where it is. All right. Let's see if I can pull your shell down here without too much trouble. It's going to go on top. No telling what I did with your other stuff. Okay, but we have your Blackboard shell. And on the left toolbar, let's see. This was Module 5 that we were in. So it should be in Module 5. And I might have put one in your note template. If I didn't put one, I will send you a link to one. I didn't put one. Okay. Sorry. Let's see if I gave you the video for mixed factoring. So I'm just going back where we were. We went in through Module 5. And I'm going to look at the videos for a second. Oh no, it's not there. Let's see if I accidentally put it in Module 6. I did not. I will add you one. All right, and it's just, I know I have it in my other course, the lower level course, but it is really a good little video, and it has that same strategy that I just showed you to help you deal with mixed problems. So I'll send that out to you. I'll put it up, but I'll send you a link. All right, so let's stop there, and I'll see you guys next time. You may have